Okay, Assalamualaikum warahmatullahi wabarakatuh. So this is lecture 5.2, part 1. So we're going to talk about shockwave. Okay, what is shockwave? Alright, in order for me to explain about shockwave, first I need to explain about the back pressure. So back pressure is actually the pressure acting on the exit of converging or diverging nozzle. Okay, so this is the pressure variation within the converging nozzle. So let me explain about converging nozzle at first. Okay, what is back pressure? So imagine pipes in your bathroom. Okay, you open up the pipes and then you try to close at the downstream of the pipe. Alright, so meaning what you do is you apply back pressure on the pipes. Okay, so let's say if you close the pipes tight enough, so meaning the water will not flow out, right? So in fact the water within the pipe is constant. So that one is basically when you have a back pressure equals to the pressure at the entrance. So similar to this converging nozzle pressure variation. So here you have a back pressure equals to P naught, which is the stagnation pressure at the entrance. So meaning the pressure within the converging nozzle is the same. So the velocity here will not moving. Okay, the air will not flow. Okay, and then you have the back pressure more than P star. Okay, this is P star. So meaning here is actually the back pressure more than P star, but the back pressure at state number 2 is less than the back pressure at state number 1. So here now, the pressure within the converging nozzle is reducing when the X is increased. Okay, so this is what happened with the pressure. So if you have this pressure, meaning now the velocity will move. The air will flow. And then here at step number 3. Step number 3 is when the back pressure equals to P star. So what is P star? Okay, like I mentioned before, P star is when the Mach number equals to 1, which is the critical pressure. So this is the lowest exit pressure possible for converging nozzle. Why? Because for converging nozzle, Mach number equals to 1, right? The maximum Mach number. So this is the lowest exit pressure. Okay, PB equals to P star, the critical condition. Alright. Okay, the thing is, this one is clear, right? So when you have the back pressure less than P star, okay, your P exit, which is P at the back, is now equals to P star. Okay, even though the back pressure is lower than P star. Okay, that is the statement. When the back pressure lower than P star, which is step number 4, but we still considers the P exit as P star. Okay, so when you have back pressure more than P star, we're going to use that back pressure as your P exit, which is this one. Okay, so that's how the importance of back pressure towards the velocity within the converging nozzle. Now we take a look at the converging diverging nozzle. So you have pressure at the entrance, pressure at the exit, and then you have throat. which is where Mach number will be equals to 1. Okay. So you have a bed pressure with many variations. You have PA up until PG. Okay. So what it means by PA? So PA here is actually when you have a bed pressure at this pressure, which is similar to the entrance pressure, the stagnation pressure. So look here, pressure is the same within the channel when X is increased. Okay, how about the velocity? If you take a look here, like I mentioned before, for state A, the velocity is 0. This is actually Mach number, which also represents velocity. So Mach number here is actually 0 because pressure is constant. When you have constant of pressure between front and back, there's no velocity within the converging, diverging nozzle. Now PB. PB is when you reduce the bed pressure, I mean you, like pipe, you open up a little bit, your you open up a little bit the pressure, you reduce a little bit the pressure. So the bed pressure here will become something like this. Okay. So now the velocity start to increase up until throat and reduce back. But here is for bed pressure at B, the value is reduced not until the throat become sonic flow. Okay, critical condition. How about PC? PC is when the bed pressure is reduced further and it achieves sonic condition at the throat. So that is PC. Okay. Okay. So for PA, PB, and PC, you're gonna achieve only subsonic flow at the diverging duct. Okay. If you look at the Mach number here, it's actually less than 1, right? So meaning at the diverging duct, only subsonic flow. Okay, we skip a little. So we go toward PE, PF, and PG. So what is PE, PF, and PG? It's actually the bed pressure lower than the critical pressure. So when you have the pressures, those three pressures, PE, PF, and PG, lower than the pre-critical, then you're going to achieve the supersonic flow at the diverging duct. Okay. Okay, now we talk about PD. PD is where the bed pressure, or when the bed pressure is high enough to produce what we call as a shock. Okay. So P is reduced up until critical value, and here you're going to achieve supersonic, but when the bed pressure is high enough, this is what we call as the shock. So you have an instantaneous jump of pressure, okay, that cause subsonic flow. Okay, so that is normal shock. So that's how shock occurs in the diverging duct. So before shock must always supersonic. After shock it's gonna become subsonic. And shock only can occur at the diverging section, okay, where supersonic has been achieved. Okay. So let's take a look shock. So this is how shock looks like at the diverging section. It's actually a very thin region to separate before shock and after shock. So now we take a look at how we analyze shock conditions before and after. So we use conservation of mass, meaning rho 1 A1 V1 equals to rho 2 A2 V2. But the thing is, the shock is a very thin line. So meaning before shock and after shock area, A1 and A2 is actually the same. So you can cancel out. So become rho 1 V1 equals to rho 2 V2. Now you have the H01 equals to H02. The enthalpy before shock equals to enthalpy after shock. Next, we take a look at the other equations that only valid for the shock. So this to calculate the Mach number, temperature, and then the pressure. 1 meaning before shock, 2 meaning after shock. So for example, if you want to determine the Mach number at the aftershock, okay, so if you have the value of Mach number before shock, so you just use this equation. So similarly, after you found the Mach number 1 and Mach number 2, then you could determine temperature before shock T1 and after shock T2. Alright, so once again, these three equations only valid for shock before and after. So I think that's all. Next, we take a look at the example. Assalamualaikum warahmatullahi wabarakatuh.